Right. Hello, everyone. Thank you for joining me for this talk. So yes, I'm Ivan Merrill. Yes, I used to be a school teacher and a tennis coach. But today, specifically, what's more relevant to you is that I have 15 years of experience working in monitoring and observability at fairly large financial institutions. So I've seen quite a few incidents that have quite a big impact, right? So one of the things that I've kind of noticed is that the approach that we take to those incidents is often quite varied. As I said, they're quite stressful. So I'd like to talk about today, in fact, a more scientific approach to incident response and see if we can come up with a way that this can help us. So one of the first things that I'd like to just point out that the tech industry overall is still pretty young, actually, compared to other industries that have been dealing with incidents. If we think about aviation, medicine, the energy sector, and particularly like emergency services, right? They've been dealing with incidents an awful lot longer than we have. And their incidents can be life or death. So, actually a lot more important in many ways than, in every way really, than the incidents we have. And so the SRE, we're at an SRE conference. Like again, when I first started in the industry, that wasn't a term that we had, right? So we're still quite young. So there are lots of other domains where safety engineering is a lot more mature than it is in us. And it's right that we go out and look at those domains and what's going on there and the research that exists to try and improve our own practices. So firstly, a definition. I love a definition. So incidents, we need to know what they are. So incidents are a set of activities bounded in time that are related to an undesirable system behavior. And there's a couple of things I'd like to point out about this definition. Firstly, it doesn't just say something broke, right? Are things balked? No, it's actually, a set of activities bounded in time that relate to undesirable system behavior. And secondly, it says a set of activities. It's not just one thing. It is a collection of things. There are a number of contributing causes. So just think about that as we go through the talk. So why do we care, right? Well, there is this unfortunate truth. So says Richard Cook, who worked in medicine, was also a software engineer, a very talented person. And he said that catastrophe is always around the corner. We're never far away from it, which is pretty scary. But it actually gets more scary, I'm afraid, in that he actually says that catastrophe is the hallmark of a complex system. So if we are building complex systems, and most of us are, and we can all heard it many times that complexity is exploding and blah, 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 actually we are coming up against catastrophe, and that's just part and parcel of it. We can never escape it. No matter how resilient we build our systems, no matter how many nines we chase, right? That fifth, sixth, seventh, whatever, right? We're never far away from catastrophe. So we need to be able to respond to that catastrophe in a good way, right? We need to be able to learn from it. We need to be able to move forward, and we need to be able to improve things. And, again, not all of that catastrophe is within our control, right? Some things are happening that are entirely beyond our control. So we need to be able to deal with it. So that's fine. But so I've seen a number of things, right? Going badly in incidents, basically. So here be dragons. And yeah, all of our slides are kind of dragon themed, which really helps. If this was simple, right? If it was really easy, I wouldn't be here talking to you, okay? But the fact is, it is hard. So I thought we'd just cover some things that I've seen happen time and time again, some anti-patterns in terms of incident response. So the first thing that we're going to cover is an over-reliance on dashboards and runbooks, okay? And what this means is that we've got a dashboard. Now, it's based on some predetermined signals that tell us whether or not our system is working. And the problem with that is that quite often in an incident, what happens is we get this mean time to innocence. We've got an alert, we've got an incident, something's broken, everyone looks at their dashboard, it's green, their bit is fine. And we go around to every team and everyone says their dashboard is green, everything is fine. I recently discovered that this is called the watermelon effect, which explains why there's a watermelon on my slide, right? On the outside, everything is green, but we scratch the surface and realize that everything is red underneath, right? And this is very easy to find when we look at an over-reliance on dashboards. And similarly, runbooks, right? we're not building our troubleshooting skills. If we are relying purely on runbooks are great and everything, but we can get to this point whereby we don't know what to do if there isn't a runbook that explains to us what to do, right? And what this means is that we're not gaining experience in how our system works. We're not owning our skills of troubleshooting, right? So in actual fact, we need a way to investigate that allows us to build that necessary experience, to find out what works and what doesn't work. Another anti-pattern that I've seen is pure guesswork, right? So here's our dragon, roll up, everyone take a guess, give it a go, right? We know we need to do something, but we don't have a clue what to do, right? Information is low. And you know what? Sometimes it does work, right? But that's luck. And luck is not a reliable strategy. You might be luckier than me, but certainly for me, I wouldn't like to rely on it. And it's not just that, right? But there are no learning opportunities you can take, right? You guessed something, it worked out, brilliant. But you can't learn anything from that. You can't improve your process for next time. There was no hypothesis about what happened, right? We just fluked it. And it's also like impossible to reliably repeat that. Yeah, you can't like reliably use luck. And I don't even want to know how you would create like a run book for luck, right? Kind of like 6 different options, roll a dice, see what happens. Yeah, so we can't rely on guesswork, right? We need a way to structure our thinking, right? And help us move forward in an incident, particularly, as I said, when information is low. So this one is a real time sink, right? Quite often, this is so common, we spend a lot of time on a particular hypothesis. We think we know what's wrong, right? We investigate it a lot. And it's easy to do because like we want to believe ourselves, right? We get an alert, there's high error rate, we go investigate the number one cause of errors, we spend a long time investigating it and then realize that actually that thing has always been erroring like that. And that was just a complete red herring. And that happens quite a lot. And as I said, it's very easy to do because we want to believe ourselves. We go out and we look for evidence that supports our hypothesis, right? This is confirmation bias. And obviously, yeah, we need to prevent, we need to stop ourselves from doing this. This is a massive waste of time, and it happens so often. Another thing that I'd like to cover is fear of failure. Fear of failure is incredibly paralyzing. It's actually one of the causes of procrastination, right? We're really, really scared about what's going to happen if this action that we do goes wrong. And I've used all the dragons here because essentially, like, everything looks like a dragon to us. Everything we can think about is scary, yeah? And, we can be in a situation whereby we think we know what's going on. We've got a great hypothesis. We're pretty certain, but we're actually delaying taking action because we're scared of what's going to happen if that's not the correct course of action, right? And that delay can, make things worse even. I've actually been in a situation early on in my career where I went to do a change and my manager told me that if that change failed, I could be sacked. Now, that's firstly a really awful thing to say to someone early on in their career, right? But also, that's not going to help me do my job, right? I'm going to be more tense. My decision-making is going to be impacted. I could be scared of doing the right thing because I've got this fear of failure. So, incidents are stressful. We all know that. And as a result, we want psychological safety. We want the ability to make good decisions and feel confident in them, but also feel safe that we've made those decisions. And that's hard to do. So we need a way to provide safety in our decision-making. I really like this quote. I've got 2 names there because everyone says it's Mark Twain, but apparently some other people think it's Theodore Reich. I'm really worried about attribution, but hopefully that's okay. So I think this quote applies to incidents as well, right? We don't have the same incident over and over and over and over again, the exact same incident, or at least if you do, I'm really sorry. You've probably got some other problems going on in your organization. Good luck with that, right? But we don't see the same incident, but we do see patterns of incidents, right? We see similar themes in incidents, similar types of incidents, right? So in this way, our incidents are rhyming. And so it's important that we learn from them, right? And we have, post-incident analysis, retrospectives, all these things to do. But, and that's great. Absolutely do that. But there are also a few pitfalls that, again, I've seen that I think we just right to cover now. So this is a really good quote. So it seems easy to look back at an incident and determine what went wrong. The difficulty is understanding what actually happened and how to learn from it. The point here is that hindsight is 20/20. Yeah, we can look back at an incident and say, well, it's obvious, right? We did a deploy, thing didn't work, we rolled it back, everything's good. That is a very simplistic view of incidents, right? Why didn't people just realize it straight away, right? If it was that obvious to you afterwards, that's great, but it clearly wasn't obvious to people during the time, right? And it's not really fair on them to kind of just simplify this thing. We've got hindsight, it's 20/20, but it's not like that during the incident. So, what can we take from this? Well, if we don't record the context of why decisions were made, then we're missing an opportunity to learn, right? If we don't understand why they didn't just understand that it was that deploy straight away, then we're not able to learn from them. And that's the whole point of kind of this post-incident process. Normative language. So normative language implies that a judgment was made and based on a particular person's perception. And again, it's really easy to do. I've got an example here. This team missed this obvious error, which they ought to have seen. And the implication there is that if they'd seen that error, everything would have been fine, the incident would have been resolved really, really quickly. But you know what? What happens if they missed it because there were a sea of alerts, right? And they couldn't actually see it out of all the alerts they had? Or what happens if they saw the alert, but didn't realize it was important? Or they realized it was important, but didn't have a clue what to do? If we apply this normative language, we lose the opportunity to learn and explore all these potential contributing causes, right? So we need to avoid that. It's also worth mentioning that, different people have different levels of experience, and what's obvious to you isn't necessarily what's obvious to everyone else, right? So the other really, bad thing that can happen around using normative language is it can lead us to attributing like a root cause or something to human failure. Incident was not caused by human failure, all right? Let's just all be very, very clear. You should not end up with some kind of contributing cause or root cause analysis, whatever you've got that says this was down to this human making a mistake, right? Again, talking about psychological safety, that's not a good place to be. So we need a way to explain why things happened in a more factual way, right? To avoid this normative language. Mechanistic reasoning. In my head, I'm not quite sure if it works, but I'm going to go with it anyway. This is kind of like Scooby-Doo villain of things, right? And our infrastructure would have gotten away for it if it hadn't been for that pesky regional database service failure, right? This is this idea that it's a very simplistic way where this caused that, right? And again, we're simplifying the incident. If we think back to our definition of incidents, we talked about a number of things, not just one, right? So not only are we simplifying it, it's almost impossible, really, for there to be a single root cause. You can always go deeper on what caused that incident, right? So we need to avoid this way of just simplifying things and saying, it was just this. And again, it removes the opportunity for learning. If we suddenly decide this was our root cause, there it was that. Fix that, problem goes away. Well, that's probably not the case. And in doing that, again, you've removed the opportunity to learn from all the other things that were contributing towards this incident. So we need to be exploratory in our approach, right? We need to make sure that we're not just kind of accepting the first thing that comes along that looks like our root cause. We need to be able to adapt as our understanding adapts. So I've covered a few kind of pitfalls of both the incidents themselves and post-incident analysis, retrospectives, and everything else like that. So now we're going to go more onto science. I obviously talked about science in my headline and everything else like that. So first we're going to go into some scientific research and a few kind of key concepts. Right, Richard Cook, who I mentioned before, incredibly talented and influential in this space, wrote a paper called Above the Line, Below the Line. And this is really important because it really makes us understand that we as humans are part of the system. The system isn't just the technology, the code, everything else like that. Those things, they sit below the line, right? We have no actual direct way to understand what's going on in terms of the bits and bytes in our computer and stuff like that. We do not interact with them directly. We interact with them via this line of representation, which might be our dashboards, our CLI tools, our keyboards and mice, right? But we're above the line. But the key thing here is that we are all part of the system. And we, in fact, are the adaptive part of the system. We are the parts of the system that are introducing change. We are making deploys. We're introducing new features. We're, refactoring our code. All of these things that we are doing are bringing change to the system. And, if you read, a really nice way for me to think about this in terms of the fact that we are part of the system is to say, what would happen if you took away all human interaction with your service? How long would it last for, right? I don't think anyone here could say forever, right? Our services need us to keep running. If you can say forever, well done, I applaud you. But the point is that, we are part of the system. We need to understand that. And in actual fact, right, incidents occur above the line. They are a human construct. When we talked about our definition, we talked about undesirable system behaviors. Who defines those system behaviors? We do, the humans. So the incidents are happening above the line, but we are all part of the system. And actually, by improving our behaviors, by improving how we respond to incidents, we are improving the overall system because we're part of it. This may seem pretty obvious, right? But change introduces new forms of failure. As we introduce, again, new features and everything else like that, our service is devising new, weird, and wonderful ways to fail. In fact, again, it's actually even worse than that. Because as we build our system to be more resilient, as we make it be able to withstand the types of failures that we've seen before, it actually takes almost more effort for that system to reach that catastrophic state. So what's going to happen is we're probably going to see bigger failures because as we go along, we're making our system resilient to all those small changes. So not only is our change going to introduce new forms of failure, it's probably going to introduce bigger, weirder, more wonderful forms of failure. But the fact is, we can't ever stop changing our system, right? We need to be releasing new things. We should be refactoring our code. We should be doing all these things that introduce change. So something to bear in mind. There's been some studies around kind of how people go around doing troubleshooting. And this is something that I think is really interesting. When we get involved in incidents, and when you're in an organization, quite often there'll be several people that just always seem to be going on incidents. And the reason that every incident ends up going to them is because they just seem to smell what's wrong, right? They seem to know. There are certain people that seem to be able to resolve an incident much quicker. They're able to understand and diagnose what's going on. They're able to prove it in the metrics and everything else like that, the signals. They know what's going wrong. And the fact is that their ability to troubleshoot has evolved over time. When you first start out, you are relying on your system knowledge, your domain knowledge. You know the technologies that are working. You understand, the architecture of your system, and you're using that to diagnose what's going on. But as you get more experience, as you actually get involved in troubleshooting, this changes to become case-based. And what that is you're thinking about those patterns of incidents, right? What's similar? What have I seen before that looks like this? Yeah, how did we solve that last time? How did we know that was the thing? And what this means is that the people that have this experience, that have kind of earned it, they're cycling through a lot of hypotheses very quickly. They're able to create a hypothesis. Oh, we saw something similar last time. How did we work out it was that? We did this. Can we do that? No. Okay, it's a different thing. So they've learned from disproving one hypothesis, they've moved on to the next, and they're cycling through these all the time. So we have to think about experience helps, and it changes the way that we troubleshoot. It's actually, you can't just share it easily, right? Experience is often hard won. So I said I love a definition. Here's a definition of science from the always accurate, never question Wikipedia. Science is a systematic enterprise that builds and organizes knowledge in the form of testable explanations and predictions about the universe. A few things to point out here. Firstly, it's systematic. There is a process at work here, right? We're not just kind of wildly guessing. Knowledge is built upon. We don't just suddenly derive at knowledge. And once we've got some knowledge, we don't stop there and go, yep, we know everything. We're continually learning. We're continually improving, right? And again, it's testable. Testable explanations and predictions, right? It's not guesswork, right? We're actually performing experiments to try and prove or disprove what we have, what we think we know. So, taking it a little step further, there is this theory of falsifiability from Karl Popper. And what this basically states is that no matter how many observations that we make that confirm what we think we know, there is always the possibility that a future observation could refute it. I've got a little quote here that I'm going to read. So, induction cannot yield certainty. Science progresses when a theory is shown to be wrong and a new theory is introduced which better explains the phenomena, right? So actually by disproving a theory, we are learning, right? And also worth noting is that we're never 100% right? Every hypothesis is just our best bit of knowledge that we know now until such time that it's disproven. But this idea that we disprove things is really, really important, right? And I think that we can apply this to the hypotheses that we use when we're troubleshooting. So let's just have a quick look. So here in more detail then. So observation, question. Well, we've actually got that from our alert, right? Our alert or whatever it is that triggered the incident says, this thing is wrong. That is an observation. And then we do our research. Well, our research is to go and look at our monitoring observability tools, try and figure out what's wrong, right? And hopefully everyone has great monitoring observability. If you don't, come see me afterwards. But yeah, so we're actually doing some research. Then we're creating a hypothesis. Yeah, we are going to say, I think this happened because of this, and we're going to attempt to disprove it. Really important, disprove it. Okay, and we're going to do an experiment to do that. And that could obviously it depends on the hypothesis, but we might take some action, we might run some kubectl commands, whatever we're going to do, but we're going to try and attempt to disprove our theory. And as a result, we're going to get some data that we can run some analysis over. Were we able to disprove our theory? Yes, okay, we learned something. Move on to another one. Were we not able to disprove our theory? Okay, well, we can take that forward from some conclusions. We've learned something now. So we have a working theory. So do we want to take that forward? Do we know enough? Or should we narrow the scope of our hypothesis and go again? So I have a hypothesis. A more scientific, hypothesis-driven approach to how humans perform and document incident investigations can improve reliability. That's what I'm saying. And here is a hypothesis. So I'm not going to go through it all, but yeah, high error rate, there is database latency, and we can disprove this, right? Some things to note about this. It is specific. I haven't just said stuff happened because of some database issue. I am very, very specific in what I'm saying. It's observation-based, right? I've used that data that I've collected from my monitoring and observability tools to come up with this. Again, I haven't just guessed. It shows cause and effect, yeah? We've got high database latency creating a backlog of database requests, which are in turn, right? Cause and effect. And really importantly, this can be disproven, okay? So why is that important? Well, let's think back to our original thing, right? We talked about losing a lot of time. If we're trying to disprove something as quickly as we possibly can, we're going to reduce that amount of time that we're wasting on the wrong hypothesis. So, yeah, why bother, right? You can listen to me all saying this, sounds great, but, why bother? And that's a fair question. So hopefully I can convince you. Let me just, yeah. we remove bad avenues of investigation. As I said, we're trying to disprove something as quickly as possible. We're not just gathering evidence that proves what we say, we're trying to disprove it. We're trying to remove this hypothesis and move on to another, better one as soon as possible. It allows for change as an incident changes. Our hypothesis is only ever our best working theory. It is not absolute, right? And incidents evolve, things change, and we need to be able to make sure that our thinking is able to adapt with that. We can formalize the language we use to explain decision-making. This is really, really important, right? We need to create a good way to communicate with each other, right? It needs to be a safe way to communicate with each other, and that leads to allow us to record our hypotheses, our thinking, and the outcomes of it, right? And this is a really crucial bit in terms of improving language, giving the context back to our incidents, and particularly our post-incidents. And then these two kind of together. So it provides a level of safety because, again, we've recorded our decisions. We can explain why decisions were made, right? We have this kind of understanding that this was our hypothesis. This is why we thought it. This is why we took our action. There is an element of safety in that because, we can kind of explain everything. There is proof to what we've done. And again, because we have all the extra context from the heat of the moment, it's avoiding normative language. We're actually more fact-based, removing that temptation to create some judgment. So, just quickly, I thought I'd end up with how to create a good hypothesis. So, John Osborne, a huge kind of star in our industry, wrote a thesis on this. And one of the first things he said to do was to look for changes. This is an SRE conference. I'm guessing quite a few people have been involved in incidents. It is that standard question, right? As soon as an incident comes along, what's changed? That's a really good place to start with, okay? We can create a hypothesis that this most recent change has introduced this particular type of failure. If that's not the case and we are able to disprove it, then the research suggests that we widen the net, right? Don't go really, really deep looking at some specific kind of answer that you found on Stack Overflow, but actually kind of widen the net. If you've got different teams involved in an incident, right, ask all of them to come up with some hypotheses and try and disprove as many of them as you can, right? Because each hypothesis that you disprove, you're learning something. And finally, don't forget Occam's razor, right? Often the simplest solution is the one that's going to work. So just don't lose sight of that. So that's it. I thought I'd leave you with this final little thing. All practitioner acts are a gamble. With science, there is no 100%, right? Just a hypothesis that we can't disprove. We have to accept that that's the case, particularly during incidents, right? We are never in a state of certainty, right? The actions that we take above the line are based on our current understanding of what's going on below the line. But we don't know for certain because below the line, that's a black box, right? We're just trying to understand it as best as we can. So we have to accept that every action we do, everything we do, is a gamble, okay? But hopefully, by taking a more scientific approach, we are reducing the size of that gamble. So thank you very much, everyone.